Today I will be talking about three aspects out of about 10 to 12 aspects of the Coastal Management Information System. This is a major project sponsored by Ministry of Water Resources, Government of India. Ministry of Water Resources through Central Water Commission has a wide experience of monitoring the riverine characteristics. They keep monitoring all the rivers, measuring the depths as well as the velocities at several locations. And this has been in progress, I understand, over a few decades. India has a long coastline of about 7,500 kilometers, including the islands. And this coastline has been experiencing a wide range of activities towards development. The development involves development of ports and harbors, tourism, coastal highways for transport, preservation of archaeological important sites. Tourism also is playing a very important role these days. These are only a few of them which I have mentioned. Anyways, it becomes very essential to safeguard our coastline. All the infrastructural facilities are already developed and also aim in the planning of protection of our future structures as well as the shoreline itself. So this program is towards the training program of Coastal Management Information System, which is termed CMIS, to provide a kind of hands-on experience to variety of measurements that is needed in order to dictate the environmental parameters that is governing the stability of our shoreline. So, Ministry of Water Resources, with a wide experience towards the riverine measurements, considered this as an important exercise to understand the coastal parameters, and hence has just initiated the program of measurement of the coastal environmental parameters at selected locations along the coast of India. And IIT Madras, the Department of Ocean Engineering, was very fortunate to be blessed with the exercise of this exercise of first of its kind in our country. So the exercise started in 2016, in fact. It went on for 2 years, and then looking at the excellent output provided by the Department of Ocean Engineering, IIT Madras, the ministry was happy enough to extend the exercise for 1 more year, which is at present ongoing. It is unfortunate that the current pandemic has hampered the smooth progress during the final year of this project. My colleagues, Professor Sanasraj and Professor Murali, will be covering few other aspects of these measurement parameters, whereas I will be covering 3 important parameters that are being measured. One is the beach morphology, next is the shoreline mapping, followed by the sediment characteristics as a last point. If you look at the beach, how exactly is a beach defined? For people who visit beach just to relax, enjoy, the beach is just defined as a surface, sandy surface above the water. This need not have to be only in front of an ocean. Even along a lake, if you have considerable amount of sand, they define it as a beach. This kind of definition is for a casual observer. But for students or researchers who are working in the area of coastal engineering in general, a beach should be defined as a stretch of the coast that extends from the shoreline or even beyond the landward of the shoreline, all the way up to a water depth of 10 meters. Now let us understand what are all these about. As I said earlier, you see that there are several rivers draining into the ocean, and these bring sizable amount of sediments to the coast. The moment you build a dam, it intercepts the sand movement, and you don't get enough sand for the beach to get nourished. So there is one small defect if you construct a dam, but that doesn't mean that you should not construct dams. So as I said, all these characteristics of the rivers have already been, measurement of these parameters already in progress. Now let us look along the coast. So this sandy surface you see is defined as the beach. The line separating the sand and the water is the shoreline. And the type of structures you construct are all shown here. This may be a harbor, or you can have a groin, a structure which is constructed for different purposes, which I am not going to emphasize here, or near a mouth of the river. What would happen is, sometimes you have a beautiful beach, as you can see here, without being affected. Now, we have seen what is a beach, but what is a shoreline? A shoreline, as I said, is the line separating the sand and the water. This shoreline constantly undergoes motion, quietly changing its configuration. For a person who is visiting almost every day, he may not know the movement of this, he may not feel the movement of the sand during a non-monsoon period, under normal circumstances. What is actually happening is, when the waves are coming and hitting the coast, there is a flow which is taking place along the shore, and these are called as longshore currents. So they are going to pick up the sand along the beach and they are going to transport. When the sand is picked up and it is set in motion, you see the shoreline is going to undergo certain extent of deformation, which depends on the size of the sediments that are available on the beach, which ultimately must have brought from the waves, the details of which I am not going to cover, and there are some sand brought by the rivers. Two things happen. The velocity should be good enough to lift the sand and propagate along the coast. Or if the sand is quite heavy and the velocity is less, then the sand will be settling there. Now you see, you have a velocity moving, you have a sand along the beach. So the interaction between these two is very important. So the parameters that are dictating the velocity of the flow are the waves are defined by the waves, which will be covered by my colleagues, and also to certain extent tides. And anyways, when these sand are constantly moving along the coast, and the moment you construct a harbor with some kind of a structure which is termed as breakwater, then what happens? The shoreline, the sand gets deposited here slowly, and then you see that a beach will be advancing towards the shoreline, towards the ocean. Whereas on the other side of the breakwater, you can see that the sand will be removed and it will be transported. This happens even in the case any kind of an obstruction. The other problem is, there are formations which are called as sand spits, or this can also lead to deposition of the sand. As I said earlier, there are two parameters. One is the weight of the sand, and another is the velocity of the current. So if the sand is quite heavier, it will slowly start settling down around this area, which is the approach channel to the harbor, and this will result in reduction of the water depth, that may even lead to grounding of ships. So hence this depth need to be maintained, and again this will depend on the size of the sediments, the velocity of the flow. So when I say sediment size, it also conveys sediment characteristics in general. So now we see that in case of this kind of a situation, how do we go about? So we need to look at the beach changes, the shoreline oscillation, how the shoreline is behaving, and what are the types of sand material, what are its size, etc. So this is very important. Then let us start with Why beach profiling? Beach profiling is done in addition to the sedimentation analysis to understand or investigate the beach processes and the effect of waves, currents, tides on the beach, the effect of structures on the beach. That is what I had explained through the earlier slide. Comparing the beach profiles measured over seasons. For example, along the east coast of India, we experienced two monsoons, northeast monsoon and the southwest monsoon. And the beach profile or the beach response would naturally depend on the monsoons. The assessments are based on field investigations, sometimes laboratory investigations, computer analysis, which has become very handy. We use spreadsheets and also some kind of presentation in order to project the phenomena to engineers, scientists, or even a layman. So all these years, the wave data and other data, the beach profiling had been carried out by the respective state governments through the public works department or the irrigation department, etc. But only that was covered, that is, only the beach profile changes. But why are we doing here? We are doing it here because we are measuring the entire host of parameters which can provide us not only voluminous of data, these data are more accurate and can provide us results of the behavior closer to reality. So, I have just said a continuous monitoring along the coast is mandatory for the assessment and maintenance surface. On the right side, you can just visualize how the erosion is in progress. This probably during when there is strong waves. So it picks up the sand and removes it and takes it further inside. So you see, at certain stretches, 15%, 50% or even the entire coastal highway is swallowed by the ocean, by the waves. So now, there is an urgent need to understand the physical processes, which is already known to a certain extent, but then for planning and design of these mitigation measures, a number of parameters are required which are being carried out through this project. On the left side you see a beautiful beach on top. On the left side bottom you see the pictorial picture of the erosion. When you look at the data needed for the beach dynamics, we need the oceanographic tides, waves, current, sediment, load, salinity. From the meteorological point of view, we also need some information on the wind characteristics, cyclones, etc. Or in general, I would say coastal hazards like cyclones, tsunamis, etc. In fact, we were fortunate enough to monitor a shoreline prior and after the tsunami 2004, and we got some valuable information along the north of Chennai port. Added to this, we have yet another parameter, which is nothing but the sea level rise, which is being talked about. Now let's look at the method adopted for profiling the beach. The first and foremost step would be, with the help of altitude, that is nothing but the chart datum or the MSL provided by the Survey of India. The standard benchmark is fixed using RTK GPS, which is defined as real-time kinematic global positioning system. This is a satellite navigation technique, quite advanced. Accuracy is very good, excellent in fact. A few benchmarks near the site which is supposed to be surveyed is established by RTK GPS for periodical beach survey. The details of this equipment used will be explained by the staff of CMIS, who have been involved in continuous measurement of the beach profiles. From the tide table, which is published prior, the tidal variations along the coast, the time of occurrence of the spring tide is known prior, and this is noted, and this is in fact to fix the lowest low water line to facilitate us to cover a wider range of the beach width. Because if you don't do this, then you might land up in error. Once this is known, the survey team with all equipments will visit the site and plan for the fixation of the survey instruments. Prior to this, the initial task will be to transfer all the levels from the established benchmarks and then commence the survey. Always, it is quite essential to get the monthly surveys. Although fortnight surveys also would help, but monthly surveys should be good enough, and it is done only during the occurrence of spring tide, so that a direct comparison is possible and thus enables the capture of monthly or seasonal variations. Prior to commencing the survey, a baseline is established. So first is the benchmarks have to be established, then a baseline has to be established. So maybe you can use the Google Earth to fix the initial baseline. For initial fixing of the baseline, this could be adopted. Or you can look for some permanent structures, mostly parallel to the coast, that can be treated as a baseline. All the levels should be then transferred to that baseline which we are fixing it. Once all the levels are transferred to the baseline, we can take it as base reference for all the monthly surveys. So one advantage of this RTK GPS is that it has access of all the three coordinates x, y and z with a high degree of accuracy, the details of which will be again provided to you by our field staff. So what happens is, since it can give with a high degree of accuracy, a profile, a transect is selected. First, a transect is what is meant by a transect? A line perpendicular to the shoreline jetting into the ocean. And along this transect, you try to locate or try to have this RTK GPS and try to get the values of the levels. So you can increase or decrease the interval over the transect. This depends on so many other factors, maybe how wide is the berm, how flat is the beach, etc. This needs some experience, and that you will get it within once you start doing the survey. I think you will automatically feel where you should go with closer intervals, where you can extend, because this can be kind of time saving for us. The number of transects depend on the length of the coastline which we are dealing with. For example, if you are dealing with say 1 kilometer coastline, it can be about 10 transects, that is 100 meters interval. Sometimes there are some very important projects which may be coming up, and you may be asked to do it at closer intervals so that they get a finer aspect. So you, with this number of transects, the amount of sand that is deposited or eroded can easily be calculated, which can again depend on month-wise or season-wise. By this you can understand the nature of the beach, its characteristics, etc. One important aspect is to maintain proper tide time. That is, start the survey half an hour prior to the tide time, that is spring tide, and try to complete the survey within an hour or hour and a half. So this is what is meant by this is how the beach profile is done. Now you look at what we have done here. This is Ursula River under this project, and you have two training walls here so that the depth here can be maintained. So in this exercise, what we are trying to do is, we have the transects here, as you can see here, and you have transects here, and how the monthly profiles are changing are plotted, from which we can draw some useful conclusions which will be reported later, which is not being discussed in this lecture. Thank you.
Now we are going to see how to do the beach profile and shoreline using RTK GPS. This one is the latest technology. Previously we are using for beach profile and shoreline marking some other techniques, but this latest technique, this have more accuracy. Here we see how to fix the instrument, how to do the survey in easy manner. For beach profiling and shoreline, first we need to shift the benchmark. That is only the based on our previous used benchmark, or from we can get from the Survey of India benchmark. Here we have the benchmark. This one is our benchmark transferred from the Chennai IMD. We fix the instrument on this benchmark. Using this, based on this benchmark only, we will get the readings.
These are the equipments we are using for the shoreline and RTK shoreline and beach profiling using RTK GPS. So these are the equipments of RTK GPS boxes, and this one is tripod, and this one is rover staff. So these are the accessories of the equipments, and these are all the safety equipments for fall arrestor and rope for the fall arrestor and life jackets. So each and every precautions need to be taken before going for beach survey and shoreline mapping survey. So first we are going to fix base. So I am fixing the base at our already marked benchmark. This benchmark were transferred with respect to the Survey of India benchmark. Yeah. Okay. These are the two boxes of RTK GPS. So one is base and another one is a rover box. So in each box we have a GPS and then a controlling system. Same like this box. In this also we have GPS and then controller system. Now I am going to switching on it. So this works with an internal battery. So first we are going to place a battery in it. Okay. So for this we have the small one. Just as viewed here, we have to fix the battery. And in this we have this GPS works with SIM card internal GPRS. So here we have a SIM card, and it also have an internal memory. So through this SIM card's internet only, we are going to connect this base with the rover, and this both and rover and base will be connected to the server. So I need to close it. So I have placed the battery. So that's all. This is how we are going switching on. Now I am going to switch on the GPS. Just click on here. Here we can see a yellow light blinking. So now its GPS is switched on. So now I am same like this GPS. I have also switched on this GPS. See, the yellow light is blinking. So now I am going to switch on the controller. This is, as like a GPS also, this controller also works with a battery. So we have to release it. Just open the back panel. So for this we have a big one battery. So this one, just place it over the compartment and close it. And connect this again. So again now I am switching on. So here is a power button. So again here yellow light will blink. Our display will be gets on. So this is the switching on of the controller.
பாரிப்பா தெரியுதுண்ணா எனக்கு தெரியுதா எனக்கு தெரியல எனக்கு தெரியுது இப்படி வாங்க இப்படி வாங்க ஓகே ஓகே
Okay. Now we are going to fix the base in this point. So now I am going to, for fixing the GPS, I am going to take the tri branch. First we have to fix the tri branch. Okay, now next we have to center the bubble. Here we have the bubble level, so that we need to center it. First we need to fix the tri batch exactly at this X mark. Now we have centered the bubble level with respect to our benchmark. So now we are going to establish the base using the GPS. After fixing the tri batch, I am going to fix the GPS. For GPS we have another one stand. So this is the stand where we are going to fix the GPS. In tri branch there will be holes, just fix it, and here you will see a clamp. So just lock the clamp. So just lock it. Just lock it. See, now it will be locked with the tri branch. Now we are going to fix the GPS over it. This is the GPS which we have switched on before. See, we can see the lights blinking. So just rotate it. Yeah, that's all. So here we can see the indicators, light indicators. So here it's showing the Bluetooth it's on, and this is the GPS location marking. So it's also in on, and this is the since it's acting as a base, it sends the data out. So that's why in this arrow mark it's blinking. Suppose if it receives the data, this arrow mark will blink, because now it's acting as a base. So sending the signals light is blinking, and this is for battery light. So these are the indicators in the GPS. So next we are going to give the offset. So this is our surveying the benchmark. From this benchmark, at what distance our GPS is located. So that distance we have to measure. So for that I am using one scale. So this is the scale given by. So this is the scale given by our OEM manufacturers itself. So I have to fix it in over the instrument. So just fix it. So this offset null already will be included in this, and just we have to release the tape. So place it straight towards the benchmark point. Towards the benchmark point. Now here you will see a white mark and a mark. So just note what is the value of this mark. So here 1.256. So now the height of the instrument height is 1.256 meters. Now we are going to configure this GPS. So for this I am taking this base controller. This is our base controller. So now it's connected, this controller and then this GPS is connected using Bluetooth. So that's why here we are seeing the Bluetooth light is LED light is blinking, and this is works with the internal battery. So this is the like a capitative page where we have to go. We are going to provide the configurations whether it's a base or rover, or it's need to communicate with the server or not. So like settings we are going to give in this interface only. So the software used for this configuration is like a capitative.
Okay, bro.
So this is like a capitative window. So in this only we are going to configure this GPS. So first you can see here yet this controller and the GPS is not connected. So once we switched on, automatically using this Bluetooth it will be connected. Now we can see that GSS sensor is connected. So which means the GPS is connected to this controller. So now we are going for the job creation. First step we have to create a job. So tab here for create new job. So I'm just clicking on the create new job. So it's got for name, so any name we can give. I'm just giving this site location name, Karakal, and just making it as a video. And then so if you want to give any descriptions or created job to this it's our wish. If you want to description is we are all going to do survey, so for what purpose we are doing this survey, so like that we can give any description. Otherwise we can leave it as empty. Then job to be stored is internal memory. In this itself there will be internal memory, so I am just clicking that internal memory. Suppose if we have any SD card, means if I have to attach it with the controller, and if I click on that SD card or USB, means it will be stored in that. So now I am going to save it as internal memory. So just clicking on it. So next the main thing is we have to go for coordinate system. So in which system we are going to process this data. So actually Coracle is zone 44. Already we have created it. Created it. This is created with the setups. So that's why so Karakal IITM, so ellipsoid WGS 1984 and projection UTM 44. These are a predefined one. So already I have created it. So just I am showing for your confirmation. Just this is now our site is Karakal, so I am just clicking on Karakal and then OK. So now I am going to save this page. So stored. Yeah, now our job is created. Now I am going for a setup. So this one I am going to use as a base. So I will have to go to switch to base. So here first of all settings. So first we need to connect this GPS with the server. In the server only the values will be corrected with reference to the geoid model. So for connecting it, I am going to set settings, connections, all other connections, and then here you can see base RTK1. Just click on it and go to edit. So here the setups will be remain same for all the survey. So make sure this RTK data format would be like a 4G, and we are using the internet connection, so GS internet 1, and click on OK. Now go to control. So this is the server ID in which we are going to save the data. So now this is a base, that's why I am using the server to use as IITM base. This one also a predefined one. We have saved this IP. There will be IP address. See, IP address, and then port. So for base, one separate port will be allotted in the server, and then for rover there will be another port will be allotted separately. So we are connecting a base, so that's why I am just clicking the base and give OK. So now it's in base. So now I am going to connect this GPS with the server. So I am just we have to click here F. There will be option FN function, or here in this button also we will have FN button. So if I click on it, we will give connect option. Just click that connect. See, our internet has been connected. So after clicking this connect, we will get the entry caster. Here there will be a Wi-Fi symbol. After connection, after successful establishment, click on OK. Just fall back. So we have finished the full setup, complete setup we have completed. Now we are going to set up the base, because we are fixed the instruments in predefined benchmark. So we have to give that setup also. So I am going for base setup. Over if you know the extra that points exact northing, easting and elevation, we can go for known point. Or suppose we have surveyed yesterday and saying that using that same point today means, also we can go for over loss point, or we can directly go for over any point. So this is our antenna height, which we have measured as 1.256 from the benchmark to this instrument level. That's the antenna height. And then these are all what in which we are mounted. We have mounted in a tripod, and vertical offset is from the scale to this GPS 0.36. These are predefined one, no need to change that. Just click on and next. Now it asks for point ID. So this is our reference point. So I am marking a benchmark one, so that's why I am clicking on BM001. Click OK. Next. Now our base will be created, established successfully. Suppose if I using same controller for the rover means, we can click rover, or it should be remained as base means you can directly go for base. That's all. These are the overall setup of base. After a successful configuration of this using this GPS, just take this controller lock and lock. So fix it with the controller and just hang it in the tripod. Now we are going to fix the rover GPS over this rover stuff. This is the rover stuff. This which we are going to. This is the stationary. This is the mobile object. So this base is a stationed one. So now first I am going to fix the base GPS over it. GPS. So this is the GPS. We already switched on it. So this pole can be adjustable up to 2 meters. More commonly we are using 2 meters. So I am fixing this pole up to 2 meters. Now I am going to fix the controller in this rover staff. So for that I am using one clamp, fixation clamp. From bottom, just insert it. And tight it. Now just take the controller. So this one rover's controller. So I am just fixing it in this clamp. So as per your convenient, so in also as per your hand convenient, just fix it and tight it. Same in this control also we have the stick. So same here also we can see the Bluetooth and GPS, and then data receiving light is emitting. So from here this GPS is receiving the data. So this is now acting as a rover. So same as a base controller, in this also we are using like a capitative software. Okay. Same as this rover, here also we will have like a interface, like a capitative interface, and a job creating options also. So in this window also we are going to configure it as a rover, and we are going to start the survey. Now we are going to connect RTK rover. So for that I am directly going for settings. Same as base setup, we are also going to create a new job. So I have created a job here as Coracle video, and for rover setup I am directly going to settings. So same connections, all other connections. For here in GS connections, same as base I have to check whether everything is same, it's connecting using mobile data or not. So just confirm it and then go for controller. So here same, this is the APN of the Vodafone SIM. Here we have used Vodafone SIM. So make sure that APN is correct for the Vodafone SIM, and go for RTK rover. So confirm whether this is connected with internet and like a 4G. Same as base, we also give RTK data format as 4G. Then only it will works good. Then click on OK. Now go for function and just click on connect. So here also after clicking on the connect, we can see the data N-trip caster is connected, and directly we can go for measure. So just go for back. So we have to enter into the main window. So this is the main page. So previously for settings we are gone for settings. Now we are going to measure it. So just click on measure. Okay. So now we can check the N-trip caster is connected and internet also connected. So here our base reference point, and here is our rover. Just click on measure. The point will be automatically stored. So whichever point we need, just move the rover. Just move the rover and just click on measure. The point will be automatically stored. So if you want to see the data, just go back. Just go back and long press this job item and view and edit data. And see, so the last point we have measured as GS008 easting, northing and elevation. So everything will be saved. Now we are successfully configured this rover and then base also. Now we are ready for the beach profile and then a shoreline survey. Now after a successful configuration of RTK base and this rover, we are now going to start beach profiling and shoreline mapping survey. The basic methodology for beach profiling and shoreline mapping survey is we have to start from a berm into the sea, we have to walk towards the sea. So that is the basic methodology for the beach profile surveying. The need of beach profiling and shoreline mapping survey is for calculating or measuring the how much of sand is eroding or accreting in this site. So that is the basic need for doing a beach profile and shoreline mapping survey. So each and every month we need to we will see beach profile, how the beach profile changing, and so shoreline mapping changing. This methodologies need to be carried out during the exact spring and spring tides, that is highest high tide and lowest to low tide. So that we during the lowest to low tide we can go into the sea as far as we can. During high tide we can't go as much as possible. So during low tides only we have to go for a beach profiling survey and shoreline mapping both during high tide and then low tide. Both the tides we have to cover shoreline mapping so that we can have better idea up to what level maximum water level is reaching, up to what level lowest to low water is reaching. So comparing that with beach profile, we can get the erosion data and accretion data in each and every site. Now before starting the beach profiling survey, we have to wear some safety measures. So now he is the person going to demonstrate the beach profiling and shoreline mapping. Now we will wear the safety gears. This is fall arrestor. Now he is going to wear it. Okay. So now we finished wearing the fall arrestor. So now one person need to hold him with a rope. So I am going to connect this rope with this fall arrestor. So these are the mandatory precautions need to be taken before we going for a beach profiling survey. Make sure you have that tighten it. Usually we need a rope length up to 5 to 10 meters. Now he is measuring beach profiles from the previous berm to, he will go inside the sea. So one person should be hold this tightly. So he will take readings 5 steps once, or wherever the beach profiling is changing, in that areas he will takes the measurements. So now he is collecting beach profiles data. So usually we will take beach profiles each and every 5 steps or 5 meter interval, or wherever the beach profile is changing, he will takes the reading. So as I showed before, just he will place the rover and he will click on measure. Automatically measures easting, northing and z values. So as he walks, one should hold this rope tight, so that if something happens, he never be fell into the ripped into the water. So in some areas we can see rip currents. So that time this safety precaution is very much useful. So that if anything happens, we can pull him. So now he is after collecting, he is now getting inside for collecting the 0 meter data
Now we will go for shoreline survey. For shoreline, we need to trace the interface line in between the water and the shore surface. That with respect to time. Suppose we keep the time. Suppose today tide time is 11:30. Now we need to start the survey before 11 o'clock. Then we need to complete the survey within 12 o'clock. Then only we get the exact shoreline, exact today tide shoreline. Suppose today tide is 0.02 na, that point we need to mark the 0.02 na, we need to keep the time at the correct manner. That is the important. We suppose if now I don't know the tide time, we will follow the how we will take the shoreline. I will tell you. We need to walk the interface line between the shore and between the water and the land. Okay. Now we have completed our example shoreline. After that, what I need to tell you now, some precautions and some information during the we need to keep something we need to keep during the data collection. What are things now? We need to keep the instrument in straight because we need to level data. Here level bubble is there. Here level bubble is there. Whenever we keep the instrument for data collection, that time we need to keep the bubble in center. At least try to keep the bubble in center, then only we can get the accurate level. Then that that tip is there na, the tip always on the tip always will be on the ground, on the level. Suppose we immerse the tip na, it will be level, we will get the wrong level. We have to keep the tip also somehow on the surface. That also we need. One more thing is what are the advantages using this RTK GPS now? We can take the continuous reading. For shoreline purpose, we need the SL level. We keep the instrument in continuous mode with the time. Every 10 seconds it take in reading. We keep the instrument like that. We can walk the interface line between the shore and water. Then we can get the position information. If suppose we no need about Z level na, we can keep the instrument like that in straight manner. Then we can walk along the shore. Then we can get the position information. That in the time basis, if suppose we keep the interval 10 seconds na, every 10 seconds it will take the reading. Suppose we put the 3 seconds na, every 3 seconds it will reading. For shoreline we take like that. Then we can take the map also. We can for what we have to locate any point na, we can make the CAD diagram on CAN diagram for this one. We can by pen drive we can get into the controller. Then we can put as a background. Wherever we want to go, there we will go by arrow mark indicating. Suppose we can some application also is there. Go application is there. We can locate the point, and where it indicates the location, it indicates the arrow. Then by using that arrow, we can go locate that point. By using, if suppose some point is some point, we have to need to locate some point now. By using that application, we can go. This and all some advantage using this instrument. We can what we will do now. We can in static mode. What is the static mode now? Suppose we have to change the point somewhere to the point. Here we have to establish our base station, but here we don't have any benchmark. But we need to transfer the benchmark somewhere. It's somewhere 30 kilometers apart. Now we can transfer the benchmark in accuracy. And what we have to do now? Here we have to put the instrument in static mode. At the same time, there also we have to put the instrument in the static mode. we collect the continuous 24 hours observation. Based on the observation, we will do the post processing. Then we will get the position of the point here with mm accuracy.